So the first video from chapter 14 is going to be an introduction to equilibrium and statics, and this covers chapters 14.1 and part of 14-2 from the textbook. All right, so what exactly are statics? So statics is the study of forces on and within structures, or rigid objects is what we're going to be looking at, that are in equilibrium. And we'll define equilibrium here in just a second. But of course, this is actually a pretty vital area of study because this is how you, if you're building a bridge, how you figure out how you build the bridge so it's not going to fall down. So if you can look at the human statics in the human body, and this has to do with how our muscles and bones and how everything works. So first off, so equilibrium. So by definition, so an object is in equilibrium if both its acceleration and its angular acceleration are zero. Now, however, just because the acceleration is zero and the angular acceleration is zero doesn't necessarily mean the object is at rest. So it just means that the velocity is constant and the angular velocity is constant. Now, we're going to be focusing on something called static equilibrium. So static equilibrium is a special case of equilibrium where the objects are in fact at rest. Okay, so there's a couple different types of equilibrium we can think about. And again, the way to think about the type of equilibrium is, so you imagine you take your object, you displace, so you have an object in equilibrium, you displace it a little bit away from equilibrium, and then see what happens. So if you have a stable equilibrium, you displace your object a little bit, and it's going to go back to the equilibrium position. If you have an unstable equilibrium, you displace it a little bit from equilibrium and it actually moves further away from the equilibrium position. And there's also neutral position where the object remains in its new position, so it doesn't move towards or away from equilibrium. So the easiest way to see this is with a little picture. So imagine you have like a bowl of some sort. So you take a marble. So the equilibrium position is going to be at the very bottom of the bowl. So you imagine you displace the marble a little bit and you let go. Well, it's going to go back towards the bottom of the bowl. So this is a stable equilibrium. On the other hand, if you're on an upside down bowl, well, now if you can imagine, right, you could balance the marble exactly right on the top, so it's going to be at equilibrium. But if you displace it at all just a tiny little bit, it's actually going to roll away from the equilibrium position. So that's an unstable equilibrium. And then if you're on a flat surface, that's going to be a neutral equilibrium because you've got one equilibrium position, you displace it a little bit, and the object just stays in its new position. Okay, so what are the conditions for equilibrium? Well, there's two of them, and it's pretty simple. So first off, there's this what's called the force balance condition. So if the net force on an object is zero, well, remember, Newton's second law says force is mass times acceleration. So if the net force is zero, the acceleration has to be zero. And remember, acceleration equal to zero, that was one of our definitions for equilibrium. But of course, that's not enough because you can have an object where the net force is zero, but the net torque is not. So the second condition deals with torque, and it's called the torque balance condition, and the net torque on an object also has to be zero. So those are the two conditions, right? And so by definition, if the net force is zero and the net torque is zero, then the acceleration and the angular acceleration of the object is zero, and by definition, you're in equilibrium. And in fact, usually static problems, all you do is you have some rigid object, you figure out what all the forces are and where they're acting. So, and you use these two equations, net force equal to zero, net torque equal to zero, and you use that to set up a system of equations that can be solved for whatever unknown you're interested in.